Now we are going to solve previous year GATE and IES questions on turning on of thyristor. This is really important because questions has been repeatedly asked in every 2 or 3 years from this topic. So you need to go through this lecture very carefully. You need to understand all the concepts and to know more about the concept behind these questions. You need to refer my lecture number 6, that is silicon control rectifier. So let's start the video.
Now see this question that has been asked in GATE 2014. In this circuit is given, okay, and for this circuit latching current is given 40 milliampere, gate pulse is applied for 50 microsecond, and we have to find the value of R for successful turn on of SCR. So SCR get turn on when anode current reaches the value latching current. Here this latching current is 40 milliampere given, and the time during which anode current reaches the value latching current is given as 50 microsecond. Okay, so we have to ensure that during this time 50 microsecond this anode current reaches the value latching current. Okay, so to ensure this we have to find the value of resistance R, or we can say that we have to find the value of resistance R for successful turn on, and when the turn on is successful, when this anode current reaches the value latching current during this time period. Okay, so here we have assumed the current through SCR is IA, current through inductor is IL, and current through this resistor is IR, and we know that anode current is sum of this inductor current and this resistive current. Here this inductor current is time varying, so we can write that first we have to find the value of inductor current. To find the value of inductor current, we will use the concept of network theory. And as I already told you, IL inductor current at any time t is given as IL infinity plus IL 0 minus IL infinity e to the power minus t by tau. Here we have to find IL infinity, IL 0 and tau. Okay, so first we know that initially inductor is not charged, so t tends to 0, IL 0 is equals to 0 negative is equals to IL 0 positive, because inductor is initially not charged, that's why it is equals to 0. Now when time tends to infinity, what happens? Inductor act as short circuit, because this is DC, and for DC in steady state inductor act as short circuit. So inductor act as short circuit. So when this inductor gets short circuited, then what is the current through this 500 through this branch? Okay, here at t tends to infinity this SCR get turn on, and during turn on SCR gets short circuit. So we simply apply KVL in this loop. So what is IL infinity? That is equals to, this is turn on, then this is shorted. Okay, so what we get? We get simply V by R. It means 100 by 500. So we get 1 by 5. Now what is tau? Tau is the time constant and it is equals to L by R. What is inductance L? Inductance L is given as 200 millihenry. So this is 200 millihenry. And what is resistance R? Resistance R is, we have to find equivalent resistance. Now to understand this, what is R? What we redraw this circuit separately. Okay, suppose this is 500 and this is inductor. Okay, this is resistance R. Now we have to find the equivalent resistance across this inductor. To find the equivalent resistance, what we do? We sort the voltage sources in the circuit. So sort this voltage source. On sorting this voltage source, what happens? This resistor get bypassed because it has sorted branch in parallel. So what is Req? It is simply equals to 500. So divide it by 500, we get what we get, that is equals to tau is equals to 200 into 10 to the power minus 3 by 500. Okay, now we have to find the IL0, IL infinity and tau. Now we can easily write the equation of inductor current. So inductor current IL at any time t is given as 1 upon 5 plus 0 minus 1 upon 5 e to the power minus t by tau. So t upon tau. Okay, so take inverse of this into 500 by 200 into 10 to the power minus 3. Okay, this is the value of inductor current. So for reliability turn on the SCR during this time period, this inductor current must be equals to IL plus IR must be equals to latching this anode current, and this anode current must be equals to latching current. So what we do, we have to actually find all these things at 50 microseconds. So we simply put t is equals to 50 microsecond. So on putting, we get inductor current at 50 microsecond is equals to 1 upon 5. Take this 1 upon 5 common, we simplify this equation. 1 minus e to the power, put t is equals to 50 microsecond, what we get? Minus 50 into 10 to the power minus 6 into 500 by 200 into 10 to the power minus 3. Okay, this is inductor current at 50 microsecond. Now we know that anode current at 50 microsecond is equals to latching current, because during this time this anode current has reached the value latching current. So IA is equals to, what is latching current? That is equals to 40 into 10 to the power minus 3, that is equals to 0.04 ampere. Okay, now what is current through this resistance? So IR is simply equals to IA minus this IL. Okay, apply KCL at this node, we get IR is equals to IA minus IL. Now what is IL? On solving this, we get here IA is 0.04 ampere. And what is IL? On solving this, we get IL is equals to 0.0235. Okay, so finally we get IR is equals to 0.0165 ampere. So this is the value of IR. Okay, now we have to find the value of R. Okay, so what is R? We know that R is equals to V upon I. So what is voltage across this resistance? The voltage across this resistance is equals to 100 volt, because when SCR get turned on, this acts as short circuit, and this voltage is in parallel with this resistance. That's why we can write voltage across resistance is 100 volt. Okay, 100 by what is current through this resistance? We have already calculated, that is equals to 0.0165. Okay, on solving this, we get R is equals to 6060 ohm. So our answer is 6060 ohm. Okay, so this is the solution of this question. Actually, these types of question are very common in GATE and IES exam, and they have been asked repeatedly in these exam. So you must understand the concept how to solve this circuit. Here they will give you a inductor. Okay, so to solve this circuit you must know how to solve the network, how to solve this circuit using network theory concept. Okay, so actually they are testing your two skills. One is power electronic skill and another is the network theory skills. So in one question they are merging the two different subjects. So you must have some knowledge of network theory also to solve these problems. Thank you.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.